Now we turn to the topic of commercializing clean energy, and I want to welcome to the stage Jeff Earl, who is the Director of Business Development for Sapphire Technologies. He leads the company's domestic and international business development. For those of you unfamiliar with Sapphire Technologies, it's a leading developer of energy recovery systems for natural gas and hydrogen applications. Sapphire's innovative solutions capture and convert energy that would otherwise be wasted, enhancing the efficiency of existing energy infrastructures. Sapphire is contributing to global decarbonization efforts and helping reshape the world's attempts to harness and utilize energy for a more sustainable future. You can learn more about Sapphire Technologies at sapphiretechnologies.com. Sapphire Technologies, all one word, no space, no dash. Sapphiretechnologies.com. Welcome, Jeff. How are you doing today?
I'm doing well, Mitch. How are you?
It's a pleasure to have you here. And I just want to ask you if you could give us an overview of the Sapphire Technologies approach to waste energy capture, and tell us, how does Sapphire's technology actually do that energy capture?
Yeah, I appreciate the opportunity. So today I am going to spend a bit of time talking about pressure. So gases are transported throughout the world based on pressure differentials. These pipelines could be moving carbon dioxide or hydrogen. There happen to be many of these pipelines moving natural gas because we use it as a source of energy. These pipelines, they're mature technology. There's a lot of infrastructure already in place, and that's both good and bad. It allows us to power the world, but it also creates inefficiencies. These old pieces of infrastructure utilize technologies which have been in place for many, many decades, and one of them, called pressure regulating valves, create an opportunity for disruption. These valves use friction to create a pressure differential within the natural gas infrastructure. Friction is like heat, it's waste. And so when I say wasted pressure energy, I mean there's an opportunity to convert that wasted pressure energy into a new source of electricity. Sapphire then, as a company, is focused on this opportunity. We manufacture a product called FreeSpin inline turbo expander. Turbo expanders are just this device which is used to convert pressure energy into electricity by a rotational process and a permanent magnet generator. So here on the screen, you see one of our projects. This is at a LNG import terminal in Japan. A couple of turbo expander systems are installed there. For scale, these systems are about 5 foot in length. They're about 2.5 foot in diameter, and they make about 300 kilowatts of power each. That's close to enough power to run 700 homes in the US. And so while Sapphire is a relatively new company, we were founded in 2021, the development of this equipment has been ongoing for about 25 years now. Our parent company, called Calnetics, has been a leader for a long time in advanced magnetic technologies. These include magnetic bearings and permanent magnet generators. Since 2011, we've been integrating those pieces of equipment into an expansion turbine, which is very similar to the product which Sapphire is offering for sale. This expansion turbine was used in organic Rankine cycles for heat recovery applications. More recently, we redeployed some of those core technologies, the magnetic bearings, the permanent magnet generator, the power electronics and control systems, into a system better suited to pressure energy recovery in natural gas applications. This started with a partnership with Baker Hughes, whereby we gained some experience in this field. We translated that experience into the development of FreeSpin. And since then, we've made several installations across the world, first in Japan, then in US, both with midstream companies and exploration and production companies. Since then, adoption has accelerated in international markets where we've made sales, again, to Japan, to China, to Brazil. Throughout this process, we've gone through a couple of different equity raises, Series A round in 2021, where investors like Chevron, Equinor, Cooper and Company partnered with Sapphire, and a B round in 2023, where Marathon Petroleum and Energy Capital Ventures became investor in the company. So let's go back to pressure letdown processes and how this system is actually integrated. Here on the left side of the screen, you see a traditional pressure letdown station. Again, the valves are in the middle here, and these are using friction to create the pressure differential from the upstream to the downstream. Very reliable process, but again, the problem is that these valves don't have the ability to recover any energy. They're just using friction to create heat to create this pressure differential. Whereby our equipment can be installed in this infrastructure to recover some of that energy. We can install turbo expanders on an independent redundant bypass line to these pressure letdown processes. We can use additional valving to direct an appropriate amount of flow to the turbo expander to make the desired amount of power. This has the benefit of eliminating the friction, eliminating the heat, and instead converting that energy into rotation within the generator, eventually creating electricity. And of course, there's ancillary benefits here. There's no combustion of this natural gas as it moves through the turbine. We're just utilizing the pressure differential. This allows us to take all the benefits associated with clean power production. It helps these oil and gas companies who are operating natural gas assets to meet their environmental targets, and it promotes a very attractive financial return for these companies as well. Just a bit more about the operation of the system. So high pressure gas would be on the left-hand side of this picture with the low pressure outlet side gas on the right-hand side. We direct the high pressure gas to an expansion turbine wheel. As the gas is moving through that wheel, it goes from high pressure to low pressure and causes the wheel to spin. This wheel is directly connected to the permanent magnet generator. So when the wheel spins, the generator spins, and it makes the electricity in the stator. We pull the electricity out of this rotating housing. We send the power to our power electronic system, where we condition the power with inverters, and we provide the end user the equipment with grid frequency and voltage compliant power that they can use to either offset a load that they have on site or send back to the utility grid. I talked about some of these applications, but when I think about our markets, I think about the whole natural gas infrastructure. That's from the upstream wellhead, where the gas is coming out of the ground, all the way to the refinery on the other end of the pipeline, where it's being refined into the different oil and gas components which we use in vehicles, in our homes, etc. Everywhere in between these two endpoints are pressure reduction processes, because the gas has to go from high pressure to low pressure to move throughout this network. So there are applications for turbo expanders throughout this infrastructure, both on the natural gas side as well as other pipelines, again, like carbon dioxide, air, and hydrogen.
Thank you, Jeff. That's as I've been doing research on this topic, I found that 10 to 50% of the total available pressure energy that's in the oil and gas infrastructure today. What's the general time to ROI when Sapphire's technology is installed?
The biggest driver for our project financials are the local power price, which is in effect. This varies both from state to state, but also certainly from country to country. In the U.S., we typically see project ROIs being less than 4 years, and in some cases much sooner than that, because of available incentives or relatively higher power prices.
So do you see harnessing waste energy as an interim step towards completely clean energy, or is this in itself, because it milks this wasted energy, a part of the long-term solution? Is this how we get to that completely clean system?
I do truly think it's both. One of our investors, Energy Capital Ventures, is developing a platform around what they call the green molecule. And this is a sustainable kind of natural gas infrastructure. So they make investments into companies which can promote the longevity of this natural gas sector overall. I like our technology because we can have both an immediate short-term impact on the overall environmental compliance of this sector, but also provide them with a technology which can be integrated and operated for the next 30 years. I believe that natural gas will continue to be a key power source for both the US and the world as we expand population and lift people out of poverty. It is necessary then for us to be good stewards of that natural gas infrastructure and drive out all the inefficiency which we can.
What are the typical challenges in the adoption of this kind of a system?
Yeah, one of the good things is whether you're US, Europe, Asia, India, the natural gas transmission system looks relatively similar. Some of these assets operate at different pressure regimes, either for safety or other reasons. Some have different regulatory schemes and certifications which need to be met, either on the pressure side or the electricity side, all of which are relatively easy for us to accommodate in our product design. So when I make a system and I install it in the US, it's not a huge challenge for us to adapt that system to, for example, a project opportunity in Brazil. One of the more challenging events which we are witnessing within the project development cycle is the time to interconnect the system. That is the time from when I go to a electric utility asking to develop a power project on their grid to the time where I'm granted a license and application to actually execute that project. The duration can be quite long. And so for us, our goal is to recover as much of this pressure energy as possible over a short amount of time. It's challenging when we're met with timelines like 12 months or 18 months or longer with some of these project developers because of the delays that they have with processing interconnection applications.
Do you find, though, that because of the urgency of reducing the impact of the oil and gas infrastructure, that the regulators are beginning to not necessarily relax, but at least speed up the review process?
One of the challenges is they are separate departments, typically within a country's regulatory scheme. You might think that it would make sense for gas infrastructure and electric infrastructure to be regulated by the same body, but that is not always the case. What I will say is the oil and gas industry has begun to adopt this technology as best practice. They see it as a responsible way to recover this waste pressure, eliminate the inefficiency within their system. Electric utilities across the world do recognize that there is a challenge here. As more distributed energy resources are put onto the grid, they're facing more and more applications. Even in the US, the DOE recognizes this as a problem and has launched a series of engagements to try and reduce the interconnection process overall timeline.
And could you give a couple of examples of successful implementations and what kind of impact did they have for the client?
Each of these turbo expander systems manufactures 300 kilowatts of power. The amount of power which can be made is related to the pressure difference between inlet and outlet of the system, as well as how much gas is flowing through the turbo expander itself. Mm-hmm. So projects can look bigger or smaller depending on which part of the natural gas infrastructure we are creating the project in. In any case, the electricity which we're producing in the turbo expander is clean, which has a direct impact on those operators' Scope 1 and 2 emissions. They are preferentially looking for projects like this. And what we are trying to do with our equipment is give these operators a way to really use their existing infrastructure to create this power. It's utilizing assets which have been in place for in sometimes decades to improve the efficiency. I look at this as being categorically different than a natural gas transmission company approving a solar project or a wind project. Instead, they're using their core competency, the operation of these pipelines, to develop clean electricity. It's a responsible way for them, I think, to meet their environmental goals.
And do you see widespread adoption of the technology beginning to take hold? Tell us a little about the traction that you're finding in the market.
Our goal in creating this turbo expander system was to provide the market with a cost-effective way to recover pressure energy. Turbo expanders are not necessarily new. In fact, they've been used in liquefaction processes for more than 50 years at this point. The problem with those systems are they are highly engineered. They're specific to each individual project. Consequently, they have relatively high capital costs as well as operating and maintenance costs. In developing the system the way that we did with these best-in-class magnetic technologies, and by focusing on modular design, which we can easily transfer from application to application or country to country, we are driving down both O&M costs as well as capital cost. So it's providing the market with a financial opportunity, something that they can make money on, as well as make good on their environmental commitments.
Does Sapphire help connect installations with sources of financing for this kind of project? Is that something that we can do to accelerate the engagement with reducing our emissions?
Yeah, there's a big market for project development. This has been historically true for wind projects, solar projects. There's an appetite within that market to also sponsor pressure recovery projects. And so we are building a partner network throughout the world. There's been particular interest in the US and in Brazil to engage in opportunities like this.
And how can our listeners get involved, those folks with capital who want to see the financing of these projects move forward?
Yeah, like I mentioned, there's a real opportunity here. We have a network of opportunities that we are working with across the world. If there's interest in any particular geography, please do let me know and I can connect you with the asset owners directly. We do feature some of our partners on our website. So if you're looking for an example of how other companies have entered into this space, that would be a good place to start.
Well, I want to thank you, Jeff Earl, for sharing the Sapphire Technologies story. Folks, stay tuned for our next conversation. It's a sponsored discussion between David Kirkpatrick and Doug McKeague, who's the editor-in-chief of The Climate Capitalist. They're going to be reflecting on what happened at Climate Week in New York in September and looking ahead to COP29 in Baku, Azerbaijan. It'll be a fascinating discussion. We'll be right back.